In this malware challenge, we examine the specimen Chrome Update Service.exe. Now this is actually a reverse engineering challenge. And what that means is that we're interested in understanding how the malware works so that we can recreate it using the programming language of our choice. You can download the specimen at the Dropbox link in the description and here at malwarechallenges.com. Remember, the decrypt password is malware123. With that, we'll begin our reverse engineering challenge. We'll start by running strings2 against this malware specimen in order to gain insight into its functionality. As we scroll up, several strings catch my attention. The first is a set of libraries used in the networking APIs in the Windows operating system. This suggests that the malware is network enabled. If we continue scrolling up, we'll see a few more interesting strings. We see Google Updater.exe in what looks like a parameter in a web HTTP request. We see RunDLL32.exe and what may be a hard-coded IP address as part of this HTTP exchange. While these strings are interesting, they're not exactly conclusive. So in order to understand more about this malware, we're going to have to run it. We'll start by opening our monitoring tools, including Wireshark, Process Monitor, and we'll be sure to disable Process Monitor so that we don't run out of memory. And we'll go over to Remnux and enable some additional tools. We'll run fake DNS, inetsim, and we'll forward all traffic to our Remnux workstation. We'll switch back over to Windows, and we'll prepare to run the malware. I'll enable Wireshark, so now we're capturing packets. And I'll enable Process Monitor. We'll go ahead and run the malware, running as administrator to see its full capabilities. It looks like the malware executed, and it downloaded the inetsim default binary. If we take a look at Wireshark, we can actually see that a file, googleupdater.exe, appears to have been downloaded. We'll follow the TCP stream, and we'll confirm that a portable executable was downloaded to the infected system. We can find more activity looking in Process Monitor. I'll first apply some filters to highlight the activity that may be interesting to us. We'll filter on operations, and we'll look for operations with the name process create. This will tell us if there are any instances of new processes being started on the system. We'll do another filter of TCP connect, which may show us some interesting network activity. We'll apply the filters. And now we can see some interesting events. First, we see that the Chrome Update Service.exe has connected to the IP address 23.102.12.13 on TCP port 80. This corresponds to the IP address that we saw in the strings output a little bit earlier. We also see that the Chrome Update Service has started the process RunDLL32.exe. So from this snippet of activity, we can basically glean that when we run Chrome Update Service.exe, it downloads the file RunDLL32.exe, writes it to the file system, and executes it. We can also see that it wrote RunDLL32.exe to our desktop, and if I run it, then it executes as the inetsim default binary. This basically proves that Chrome Update Service.exe is a download execute piece of malware. But in order to make sure we didn't miss anything, we're going to have to resort to code analysis using IDA Pro and Ollie Debug. We'll drop the specimen into IDA and accept the default options. We'll take a look at the imports, and we can start inferring the behavior of this malware based on the libraries that it imports. You could see calls to create file, which is consistent with the run DLL32.exe we saw dropped on the file system. And if we scroll down, you can see a number of libraries used for networking, namely the WS2_32 and WSOC32 libraries. We can see more interesting information by dropping Chrome Update Service.exe in Ollie Debug. I'll press Ctrl-N to take a look at the imported libraries, and we'll scroll down to the calls to the WS2_32 libraries. And I'll pick this second one here that says WSAS send. We'll double click on it, and I'll set a breakpoint at this location by pressing F2. We'll run the specimen, and it should pause on the breakpoint. And then if we scroll on the bottom right to see what's on the stack, we can see parameters to what appears to be the HTTP request. And here you once again see the hard-coded IP address. You see the file that it requests, googleupdater.exe, and it also gives it the user agent of WinINetHost, which could make for an interesting indicator of compromise. At this point in the analysis, we know all there is to know about Chrome Update Service.exe. We know that it is a download executor program. Essentially, it grabs a file from a remote web server and then executes it. So now that we understand the malware, we'll solve the next portion of this reverse engineering challenge by recreating the specimen using the program language of our choice. In my case, I'm going to use Python, but feel free to use whatever programming language you are most comfortable with. Now I wrote two programs in Python to illustrate how you can solve this challenge. The first way is to replicate the activities of Chrome Update Service.exe exactly. And to do that, I wrote a program called Chrome Update Service.py. So we'll go ahead and run it. And you see that it downloaded a file, rundll32.exe, and it executed it. Now a better way to solve this challenge is to repurpose Chrome Update Service.exe into a program that can basically download and execute a file from any remote web server. So that's what the second program is, download_execute.py. We'll go ahead and run it, and we'll give it a remote resource. We'll say evil.com and evil.exe, and we'll write a program called calc.exe to the current working directory. We fire the script, and as you can see, it downloaded the file and it executed it. We'll take a quick look at the source code, which can be found on malwarechallenges.com. So here you see the first code snippet. Essentially, we make a HTTP request using the requests library and the get method. We specify the remote resource, and then we create a file object, in this case rundll32.exe. We write it to the file system, and then we run it using the os.system library. We then take that same script and extend it so that we can point it at any remote web directory. We use the sys library to take command line arguments. We assign them to the variables web server and file name. And then the rest of the script is the same. We do a HTTP request to the specified web server. We write it to the file system using the specified file name, and then we execute it. So that wraps up this reverse engineering challenge. We took an unknown specimen, we figured out that it was a download executor, and then we recreated its functionality using Python. I hope you enjoyed this exercise and that you learned some valuable new skills. Keep practicing, and thank you very much for watching this video. My name is Blue Sentinel, and I look forward to seeing you on malwarechallenges.com.